Welcome, everybody. It's really a pleasure to be holding another Carney Conversation. I'm Diane Lipscombe, Director of the Carney Institute for Brain Science, and I'm here with my colleague, Chris Moore, Associate Director of the Institute. And he and I are going to be prompting questions during this really exciting discussion with Ellie Pavlick and Thomas Serre. And so I'm going to do a quick introduction of them, but just first of all, wanted to welcome you and thanks for spending this hour with us. It's going to be exciting. We're going to talk about ChatGPT, as you well know. So I'm going to introduce our guests, our colleagues at Brown, local experts. And I just want to remind you all that there's, we'll be taking questions. And so we really are encouraging you to post some questions in the Q&A tab at the bottom of your screen. And then Chris and I are going to be reading those, and we'll kind of combine a few depending on what's coming in, and then we'll post them to Ellie and Thomas during the session. So that's the plan. So delighted to welcome Ellie Pavlick, who's an assistant professor in computer science at Brown University and also a research scientist at Google AI. Ellie and her group are interested in building better computational models of natural language semantics and pragmatics. That is, how does language work? And how can we get computers to understand it the way that humans do? Ellie's also, which has been great for us, is on the Carney Institute for Brain Science Executive Committee. And so we're getting a lot of feedback from her as we think about the kind of the overall the brain science community. So welcome, Ellie. Thanks for joining us.
Thank you so much. I'm happy to be here.
Yeah. Thomas Serre is also with us, and he's a professor in cognitive, linguistic, and psychological sciences, and also in computer science. Thomas is the faculty director of the Center for Computation and Visualization at Brown, and he's also an associate director of the Center for Computational Brain Science, which is in the Carney Institute. Thomas and his group studies the neural computations that support visual perception. And he's very interested in the computations carried out by the visual cortex, like how do our brains do what they do, and how do they perceive images from very complex backgrounds. So I think this combination, and thanks Thomas for being here too. We're super excited about this combination of having Thomas and Ellie, and so yeah, here goes.
Thank you for having us.
Yeah, welcome. So, I thought it's just really great to kind of have everybody know who you are. And so I just wanted to get some quick intros from you both. Start with Ellie. How did you get where you are, Ellie? What's motivating you? What do you love about what you're doing? What was your background before you got into computer science and Google AI?
Yeah, I mean, I think, I don't know, maybe a lot of people have like a really clear, like I got into this field because I've always wanted to study how language and computers or something. I think I kind of like slipped into it or something, right? Like it's kind of just like a series of decisions, and now I'm here, and I can't imagine working on anything else, but it's but it wasn't like a super conscious decision. I think I wasn't a computer science major. I studied economics and actually music undergrad. I took some CS classes for kind of random reasons, liked them, kept taking them, wanted to get involved in research. The only person who had openings for undergrads worked on kind of language stuff. So I started working on that. Not this particular type of kind of starting working on that. Then it just over time, it became apparent that the most interesting questions are ones that kind of work more at this intersection and both computation and the cognitive science and stuff like that. So it's been like a gradual, and now it feels like an inevitable, like, of course, this is what I would be working on, but I don't have a great origin story, I guess.
That was great. And that's a really nice shout out to all of those undergrads and high schoolers, if you're out there, like, just because you haven't always dreamt of being a computer science. So.
Absolutely.
Could be in your future. Thomas. Thanks, Ellie.
Yeah, so I was born and raised in France. I studied math and physics as an undergrad, and then I attended a graduate engineering school in the equivalent of ECS in the US. And there I specialized in image processing. And we had a few lectures on artificial neural network. And as soon as I started to hear about artificial neural networks, I realized that I was truly genuinely interested in understanding, the biological side of things. And being in a engineering school in France, there was no opportunity to learn about the neuroscience kind of background. So I don't know how much time I have, and maybe I should avoid like the cheesy stories, but the story is that around that time, I was watching a documentary on the BBC, and they were talking about mad scientists somewhere that were able to hook up computers with cultures of neurons, and they were able to send signals, electrical signals from the computer to the neurons, and simultaneously recording, neural activity from this dish. And I saw that as an engineer, especially in telecommunication, and I was like, this is it. That's what I want to do. And the place where they were doing this crazy research was called MIT. So I had to go on Alta Vista at the time and figure out where this place was. And I realized this was in Boston. This was called the Massachusetts Institute of Technology. And so I immediately I found groups there that were studying, a blend of natural artificial intelligence applied for an internship there. And when I got there, this was heaven on earth. So I applied for the PhD program, studying neuroscience, and a few years later, here I am at Brown studying computational vision. So I had an interface between biological and machine vision.
So you have an actual moment you can peg your interest in. I need to create a story like this. It's better to be like, this is the moment I knew. That's great.
There is an application out there, Ellie, that you could use to create your really interesting story.
Yeah, ChatGPT, please give me a really inspiring origin story for the moment.
There you go.
Yeah.
And there's no way to check Thomas' story also.
Right. Right. Yeah. Absolutely. Yeah.
It is a true story.
So I think what would be great to start off with is, Ellie, if you give us like a 101 intro to ChatGPT. What is this and what is it not? Fire away.
Yes. So I guess at a very basic level, it's like a machine learning model. It's an artificial neural network that Thomas was mentioning, but it's a type of machine learning model. It's basically a system that was designed to predict the next word in a sentence, right? So this is a very simple task that we've been working on now for many years in my field, natural language processing. You say we want some big system that's able to just guess the first word of a sentence with very high accuracy. You say start a sentence and it says the, and you say, okay, good job. If you just said the, what do you think the next word is? And it's like child, and you're like, okay, cool, you said the child, what comes next? And it just does that, and it's trying to guess the next word in a sentence for all the sentences like on the internet, right? So it's just a giant model that's trained to do something like that. And then what ends up coming out when you train a system to do something like that is some surprisingly impressive kind of system that seems to understand language in this really interesting way, where you can ask it questions and have a chat and it's responding to you. There's a few other bells and whistles that go on top of this predicting the next word, but the truth is not that much, right? So that's like most of what it's doing is predict the next word. And when you do that with a large enough model over enough data, it seems to pick up these really general patterns that that give the appearance of being able to generate very realistic sounding articles, stories, poems, dialogues, writing plays. It can generate fake news reports, fake scientific findings, like all kinds of things that really, really seem real from the patterns it's picked up, being able to do this very basic predict the next word task.
So Ellie, can I ask you a little bit more? This is great. When you say it, like what, is there a physical entity that you are talking about here? And,
that's a good. Yeah, so it's a machine learning model. So for like very like it's basically a computer program right? That's like, but it's a statistical association between kind of inputs and outputs. Like it's just some function that's mapping inputs and outputs. The it is the computer program that's taking those inputs and mapping them to the outputs.
Thank you, Ellie. And just a little quick, oh, sorry, go ahead, Chris.
Well, I was just going to ask, ChatGPT seems like a real inflection point in, you know, the ways in which one could interact with the machine and get back something that sounds reasonable. You said there's bells and whistles, but the model you're describing sounds, like you said, like things people have been working on for a long time. So what makes it different? I mean, some of it I'm sure is hype, and that's interesting to know what's hype and what's new. So what is new about it? Or why is it such a apparent, it seems like such an inflection point?
Yeah, I mean, I think it is. It's not like there's a lot of hype around ChatGPT, like a lot of things about what it means for, you know, the world or something like that, or claims of consciousness and things. But in terms of technology, it is exciting. It's I think kind of what you're commenting on. So there's, I mean, since the dawn of ages, like people in computer science have been trying to build models that have this kind of behavior, right? That you can talk to in natural language, right? A lot of the ways that people would do that traditionally requires like a lot of structured knowledge and semantic representations, right? The model will have access to a database. It'll have access to all kinds of you know, kind of traditional computing components in order to like reason over complex things. So if I were to ask it questions, it's going to parse it into some database query language and run some retrieval, right? Like that's kind of the way that people always envisioned a system with this type of behavior would have to work under the hood. What has been the trend recently, I mean, so artificial neural networks have been around for a long time, and models to do this predict the next word task have been around since the 80s and 90s, right? Like that's not a new idea. But people have been kind of plugging away on that. And really in the past 5 years, the big insight has been, let's just make the models really, really big, which is not like, let's just give them a ton of data. It's kind of a ridiculous thing to think that people would do, because it's like, we have this thing, it's not really working. Have you tried just investing a lot more money? Like you would think you'd be like, okay, give up. Like the initial pilots didn't work. We think there's going. It's like, no, let's just keep making it bigger and bigger. But what ends happening is as they get bigger and bigger, they perform better like this. And so there's, so I think ChatGPT itself on a technological standpoint is not the inflection point. The inflection point has been sometime over the past 5 years, there's been this increase in building models that's fundamentally the same, but they've been getting bigger. ChatGPT is definitely an inflection point in that it's available so the public can use it and play with it, right? Like, whereas before, you know, a year ago, like even just 1 year ago, like to interact with one of these systems, you need to get access to Brown's compute cluster. You definitely need to have quite a bit of tech savvy to log on to spin it up. And then the interface for interacting with it is going to be like super clunky, right? Like you dump some file that has the log of all the things it generated and you comb through them. And so like as an engineering feat, ChatGPT is a huge success. And there are a few other things they've done on top of the basic technology to make it like better behaved, like less likely to say offensive things and stuff. But I don't think it's hype to be excited about the success that neural networks are leading to in terms of just applications. There's definitely hype about the broader implications, and maybe we can talk more about that, like comparisons to human likeness, but just technologically and as an engineering thing, it's very exciting, right? Like we've wanted systems like this for a long time.
Great. And actually that's the perfect segue to Thomas. We're going to talk about neural systems and networks. So Thomas, and so Ellie, that was great. Thank you. So Thomas, what is, Ellie mentioned, like, we don't know what's going on. What is going on under the hood? Do we know? And are there parallels to how the human brain computes and interprets language, vision?
Yeah, so, you know, Ellie and I were just talking about it. I think it's fair to say that, you know, currently scientists have very little understanding of what exactly is going on under the hood. In fact, that's a big research agenda for Ellie's group, to try to understand, the better the strategy that these systems are implementing in order to solve this, seemingly human-like natural language processing abilities. With that said, there are interesting parallels with neuroscience, and I'll preface my answer by stating the fact that as computational modelers, we typically think about understanding the brain at different levels of analysis. And so those levels are typically referred to as the computational level, which is typically a specification of the function or the task that one of the functions that the brain is implementing. So this could be something like recognizing objects in images. This could be something like understanding natural language, so on and so forth. So this level is fairly abstract. It's mostly a specification of the task. Right underneath, there is what we call the level of representation and algorithm, is really trying to better understand the actual strategy that the brain uses in order to solve and implement this function. And then at the very bottom, third level is the level of hardware and implementation, which is the kind of things that people in molecular neuroscience study, and it's really understanding how neurons and networks of neurons really carry those computations and implement those algorithms. So clearly, when we talk about ChatGPT, the hardware onto those algorithms run, which are modern compute cluster, which are AI accelerators plus the standard CPUs used on everyone's computer. Clearly, that has nothing to do with the neural hardware that sits in our heads. So at that level, there is very little overlap, if any at all. What is interesting is what happens at the next level. And so there, I think there is work starting to suggest that at least superficially, there might be some connections between the kinds of representations, word and sentence representations, that algorithms like ChatGPT use and leverage to process language information versus what the brain seems to be doing. And so I think there are two interesting points here, and just to paraphrase what Ellie already said, the really important kind of backbone of ChatGPT is a particular kind of artificial neural networks called a transformer network. I should say that those transformer networks are currently pushing the state of the art, not just they initially came from natural language processing, but they've really taken over the entire field of AI. So you can go to a computer vision conference, you can go to, almost any robotics conference. Those artificial neural networks are really kind of, pushing the envelope in all those fields compared to older artificial neural networks that have been around for the past, 40, 50, 60 years. What is interesting about these transformer networks is that they have one particular mechanisms in them, which computer scientists actually call self-attention. And it turns out to be somewhat related to the attentional mechanisms that are known to take place and be carried in our own brains. So that is interesting because that's inspiration potentially that came from neuroscience, the idea of leveraging attentional mechanisms to yield better, more powerful artificial neural networks. The other piece that is kind of a key aspect of what has enabled this technology to reach the level that we have today is what, as Ellie said, the way they are what we call pre-trained. So a lot of the work that has used to happen, I guess, a long time ago in language, more recently in vision, is that we used to train artificial neural network with a lot of human supervision. So for instance, in vision, to train a system to perform image recognition, people would collect very, very large database of images and then, perform annotations by hand, for instance, drawing bounding boxes around objects, labeling the category of objects. And so that's typically very tedious, requires a lot of manual work. And that's what we call the supervised learning approach. What is interesting with large language models, modern large language models, such as the ones used in ChatGPT, is that they are trained with this without the need for this explicit human supervision, at least this backbone. As Ellie said, a lot of it is predicting kind of the next word. taking into account some broader context. That is interesting because, first of all, they require far less supervision than the artificial neural network we used to have. But second of all, it's it seems to be somewhat related to what I would say a very influential modern theory of brain theory known as the predictive coding theory. And so that is a hypothesis theory that has been postulated probably decades ago, that is not fully completely tested in neuroscience, but that is one that is driving a lot of experimental work at the moment. And the idea is relatively simple in that the assumption is that our brain is constantly making prediction about what's about to happen. So when hearing someone else speak, the assumption is that our brain is constantly making predictions, expectations about what's going to be said next. There's a lot of evidence that our brain is sensitive to cases where our expectations are not met, when a word that was not expected, for instance, was uttered. And similarly in vision, the assumption is that our brain is consistently monitoring multiple things, tracking objects and things of that sort. So I would say at least at those two levels, at the level of attention mechanisms, at the level of the way, the core engine of these networks are consistently making predictions about what's going to be said. That seems to be, at least at this, course level, seems to somewhat be, consistent with ideas related to neuroscience. Now, to be just a little bit more specific, in the past, I would say 2-3 years, there's a lot of work that has been done, really trying to delve a little deeper in finding connections between the representations, the strategies used by those large language models, and trying to relate those to actual brain processes. And so people have carried experiments using very standard neuroimaging methods called fMRI, functional magnetic resonance imaging, and MEG, magnetoencephalography. While people, for instance, read text. And so, for instance, one study comes to mind that was published, I think less than a year ago, where human subjects were scanned while they were reading in the scanner. I think the study was done in the Netherlands, so these were Dutch sentences. As people were reading those sentences, their brain was being imaged. And so the researchers were able to collect a lot of data from 102 subjects. So that's a lot of brain data to deal with. But those data led to gave scientists an opportunity to understand what kinds of brain representations are being developed, are being leveraged when people speak and when they utter those sentences. What researchers have done is that they went back to these large language models and tried to find patterns of correlation between activations found in the artificial neural network and patterns of activations found in human brains. And so what they found there was quite interesting. When you look at the system, the set of areas that light up when people utter sentences, you find that early on there is an activation of early visual areas, including what we call the primary visual cortex and part of the so-called ventral stream of the visual cortex. And that's consistent with the idea that people are reading, and so they are moving their eyes to be able to read. There is then an entire network of so-called language areas that gets activated. And interestingly, this set of area is also hierarchically organized with what we call intermediate language areas, as well as higher language areas, which this is not fully understood and fully defined, but the assumption is that there is a hierarchy of processes that takes place when we speak and when we hear sentences. Now, what is interesting is that they run those scientists run different kinds of models to try to understand what was going on in people's head. They run models of vision. They ran models of language processing, but very simple ones. Models of language processing that would just try to that process language simply based on the semantic similarity between words. So, for instance, models that would know that cats are semantically related to dogs and mice and things of that sort, but in a way which is largely independent of the broader context in which those words are being uttered. And then they went all the way to this transformer networks used in ChatGPT. We haven't given you a lot of details, but one thing that is interesting is that those transformer networks, the way they are wired, allow them to take a lot of words into context. And so, for instance, typically they will look at a sequence of hundreds of words, potentially corresponding to multiple sentences, in order to build a representation of each and every one of the words in that sentence. So we can call that a contextual representation of words, if you will. So it's one step beyond, a simple semantic representation where, those representations would be able to, take into account really a broader context. Now, again, just to end on this results, what is interesting is that they found that early models of vision better predicted brain activity early on and corresponding to early visual areas. They found that this second level of representation, which let's call it the lexical representation, the one that is capable of representing something about the semantic of words without taking into account the broader context, somewhat correlated well with the activity found in intermediate language areas. And then this final model, the contextual one, the one really used in ChatGPT, was found later on, up to 500 milliseconds, half a second after the word was even uttered, to correlate with activation in higher level language areas. And so, again, this is still very early work. There's still a lot that we need to understand, but at least there is a growing body of research in neuroscience suggesting that what these models, large language models, vision models do is not entirely disconnected with the kinds of things that our brains do when we process natural language.
That's super interesting. This is really, and also thank you both for getting me even modestly up to speed on what's going on here. So I had a question, I think it's for you, Ellie, but everyone jump in. I know that you say something called pragmatics in language, which William James aside, what is pragmatics? But I think I have a follow-up question if I understand how it might fit with ChatGPT, but let me just ask you that question first.
Yeah, that's a really good question. So when we think about language, like what it means to, understand language, or what are people doing, like what are the representations in play under the hood? And I think what Tomas said is exactly, is kind of relevant both to talking about in humans, but also talking about these models, right? So we're kind of thinking like, what are the representations and the algorithms that are running under the hood that allow this? When we think about language, there's usually kind of two, conventionally the language understanding part gets kind of broken up into the semantics and the pragmatics. Of course, in practice, it's not as though these are really easy to separate one from the other if you talk to people who study language, but the kind of working definition, the intuition people haven't heard, the semantics is something like the literal meaning of things, which is, taken to, to some extent to be kind of context independent. So if I say something like, something like I'm cold, right? This is one of the classic. So if I say I'm cold, you interpret it to mean that I am saying I'm cold. There's also what we would call the pragmatics account, which is you trying to understand the meaning of, understanding the meaning of something in the context when it occurs with some particular goals in mind. So if we're standing and the window's open and I say I'm cold, I'm saying shut the window, right? So the semantic meaning is that I'm cold, and the pragmatic meaning is we should shut the window. And so both of those things are kind of important to, we would say, the full kind of human language competence, right? I think it's you can think about this in the context of ChatGPT. There's definitely questions that people are dying to ask about, can it have the semantics? Can it have the pragmatics? Which ones can it fundamentally have or not have? I've heard a lot of really, I've seen a lot of debates about well, it can't have pragmatics because it doesn't know about the larger context. It doesn't have goals. It doesn't know that people have goals, all of that kind of stuff. I've heard the same arguments made for that's the reason it can't have semantics. And I think the truth that, like, the unsatisfying answer I have to most of these questions is like, we just don't know for a lot of these things. For the kind of reasons Tom was saying, like, we kind of have the model, we see what it can do, but at a underlying mechanism level, we don't really know what's happening. We don't know like how it's representing the problem, how it's getting from input to output in a precise enough way to really say anything quite satisfying about whether it's human-like, or like if we see that if you type into ChatGPT, we're standing in a room with a window open and I say it's cold, what should you do? It'll probably say you should close the window, right? You can probably try it. That doesn't mean it like has the semantics or has the pragmatics or has one or the other or both or neither. Like that alone doesn't really provide us that. All it tells us is it kind of gave a sensible output for that input. Deciding whether it represents something that we would call semantics or something we would call pragmatics requires kind of getting under the hood, figuring out what was the process that brought it from input to output.
Right.
And then also having a story of what we think is happening in humans, and then saying, are those two processes the same? So we're in a really, really hard position right now because we don't have a good story for what's happening under the hood in ChatGPT, and we don't really have a full story in humans either, right? Like these are two unknowns, and so like, yeah, they're the same in that they're both unknown, right? But like whether they're the same, I think is a really exciting area of work that's ongoing, but I just don't think we have answers yet, right? And it could go out either way.
Absolutely. I mean, in a lot of what some people think there really isn't perception. There's just action that didn't happen relative to perception, right? That it's all an action system. It's all about what can I use this for? Where is it going?
Right.
It may not turn into physical action, but certainly in the terms of thoughts or imaginations or the things at that level of a predictive model, that seems to be something ChatGPT just doesn't have.
Right, absolutely. And I think there's a bit of a, I mean, I've talked to a lot of people here about there's a philosophical component to this as much as a basic science right now, which is how critical is the perception for having the concept of a thing, right? So color is a really clear example, and this is one. Color is something where you're like, of course there is a physical entity that is color. And actually we had some work in this lab of trying to like take one of these models that's only been trained on text, right? It doesn't see anything, it has no perception, and just trying to find some kind of evidence that differentiates its concepts of the color words from the perceptual concepts. And we can't do it. Like, I'm not saying it can't be done, but it's really hard to show in some kind of measurable, precise way that this model definitely didn't have access to perception. And Tamar could probably comment more, but I know there's similar study on like congenitally blind people who have a very well-structured, nice color space, right? They use the words correctly, they make the associations, they consider things similar and different in the same way as seeing people. And so I think there's kind of a actual empirical question to ask about whether we can find differences in the kinds of concepts that ChatGPT has or something from the concepts of people who have perception and actions and goals. I would, if I had to place money, I would imagine we will be able to find such differences, that predicting the next word in a sentence cannot be the whole story, right? But it is an empirical question. Like, we can't just, it's not by fiat the case that because the model didn't have access to goals or something, it can't have concept X for whatever your favorite X is, right?
And just a brief comment, there are at least some syndromes like Williams syndromes where children will do amazingly well in language conversations in terms of their immediate navigation of the sentences, but clearly lack a higher conceptualization of where it's going. It seems to be a little bit like that.
Yeah, that's a very relevant. I think there's probably a lot of connection, like parallels like that could be drawn and kind of inspire how to go about thinking about what kinds of things we can learn from ChatGPT and which types of things we just can't, right? Like, because if we know these things get divorced in the human brain.
Thank you. I'm going to move on to actually picking up one of the questions that got posted, and it's pretty interesting. And so the question, and there's some context to the question, but the question is there some functional parallel between the biological dreaming process and the computational process of generative AI? Now, you could answer that question. The context is that from the person, one of the participants who's listening right now, said that they were thinking about this discussion that we're going to have, and they were dreaming, and so started to combine the anticipation of this conversation and the connection to dreaming. And I won't do it justice, but I think it's a really interesting question because you know, I have a very very biological assessment of, like, you know, sleep, of course, is where a lot of the events of the day are consolidated in some form, right? I mean, we know that. But I think there's a deeper question to this, which is really around the process of dreaming, the abstractiveness of dreams. And so I'm going to repeat the question, which is really like, are there parallels? Do you see parallels in terms of the dreaming process and the computational process of generative AI?
I know nothing about the human process, so I could comment maybe on some of the things that are in play in these examples that were pointed to, and then Tamad could comment on the biological, or vice versa, if you want to say something about what we know about. I don't know, Tamad, if I don't know which direction is better to go. Maybe if you go first, it'd be easier to map what we know about how the systems work onto the story of dreaming.
I mean, yeah, I'm far from being an expert on sleep and dream. All I can say, and you know, I'm thinking hard. There's no obvious connection that comes to mind. That said, you know, there's a lot of evidence for replay in neuroscience during animals. And there's a need for you know, replay and a use of what we call replay. So the reimagination of, you know, things that have been encountered during the day that are potentially, you know, important for, you know, memory and for learning more broadly. And so there's a lot of work in AI and specifically in reinforcement learning that is leveraging those kind of replay mechanisms that, you know, has been shown to be kind of quite crucial actually to get artificial agents to be able to learn. So in this particular case of ChatGPT, I'm not, you know, I don't have a good sense. And of course, it's because we know so little about, you know, how learning of those kinds of, you know, high level functions, such as natural language processing, even take place in the brain. So it's not impossible, far from it. I don't, you know, have an immediate answer to provide, but I would say more broadly, there is something exciting that is being explored, at least on the AI side of things, you know, leveraging things like, you know, replay, dreaming, you know, in the context of reinforcement learning.
That's good context. So yeah, I mean, my gut instinct is to be like, it's just, there's not a parallel, right? Like I'm sure there is some connection to me, but my guess is it's really appealing to think of this, like, because we see these kind of cool, crazy looking images, right? Like, and they get named things like deep dream when you have like these models with like kind of, you know, trippy looking picture of your dog or something. But like one really important difference I think about, or thing to point out about how these models work, is like when you're dealing with ChatGPT or something, it's like a steady state system. It's not evolving and changing and stuff. Like that can happen offline, and the companies that produce them are constantly refining them. But like when you ask it to produce I guess in this case, it'll be like a rap song about the Krebs cycle or whatever thing you're asking it to do. It seems like, oh, that's so cool and creative, but this is like a mashup of stuff. It's already like, it's not like replaying and thinking and trying to combine things new ways in order to cement what it knows or whatever kinds of things happen in the brain, right? Like it's done. This is the system. And when you ask for a new output, it's like just going through and it's giving you the thing that's going to. It's like a one-way forward, we call it a forward pass through the network, right? There's no feedback from that. It's not reflecting on what it just did and updating its weights. So all of these things that we take for granted that a human language user is doing, which is like each time it outputs, that's going to change a little bit about what it does the next time. Like that's not how these systems are working. So I think a parallel to dreaming, if dreaming has any process of what I was talking about, replay, any kind of learning function or any kind of cementing or reinforcing function, like any of that stuff, that's not happening at all. It's purely an output in these examples. So I would say that's probably a main way that it's just processing wise, it's a weak analogy, just because these systems are not doing any updating at the point that they are like dreaming. I'm sure there are other ways as well that I would.
But one, to just maybe really super quickly follow up, because amazingly we've got 15 minutes left and questions are coming in, but I don't want to. But there is a way in which that could be imposed on the system, right? And like this is a follow-on question, and I'm just kind of paraphrasing and taking liberties, but one could imagine that there could be multiple different, ChatGPT like systems that are just tuned to and optimized for particular groups of people that you wouldn't know, but like that's a form of reinforcing certain areas that you wouldn't have knowledge of. Just based on the profile, your profile, or a certain subgroup of people's profiles. So is there other, is that the next, is that happening anyway? I mean, we know it's happening on the small scale, unknown to, perhaps known to us, but like, what do you see the future is? Do you think that this is something that's ultimately going to happen, is already happening, where you put in questions and there's probing and out comes something very individualized to you based on your profile?
Yeah, I mean, there's tons of work. There's tons of work in like very specific problems that I think would encompass that, which is in particular like doing small scale local updates to these models, right? Because they're enormous. So models of this size would train for many months on like clusters of thousands of GPUs running in parallel. They're very expensive to train. And so if you want to make a change, like even very small things, like they trained on the internet up until the day that they were, like the data was downloaded, right? So something new happens and you can't tell the model like, oh, by the way, we have a new speaker of the house, it's so-and-so, right? Like that's not something you can easily incorporate into model. And so similarly, like local context, like you can meet a new person, and well, if you're me, you promptly forget their name as soon as they say it, but other people might then retain that name, right? And like now know it and only need to be told once, and it's like new information they can use. Any other kind of personalization has this similar flavor of like a kind of a N of one, very quick, immediate update with a particular context in which it applies. Mm-hmm. And there are all kinds of creative ways that people are thinking about on how to give a similar ability to these models, but right now it's all research.
Okay, great. That's great. Thanks. Yeah. Cool. Chris?
Yeah, I have a few million questions, but luckily I know where you both, so at least offline, I'll start taking them too. I mean, there's some questions coming in here. So one of the questions, to try and summarize it, and hopefully I get it right, is that, the training set of whatever that training set is, obviously it dictates the outcome, it's how it makes its predictive model. That kind of goes without saying. But there's a big choice on what you train on. Is it proper English of a certain type? Is it culturally embedded in a certain way? And I think what one of the questions is getting at, as these large language models become a part of what we're getting answers from them, does that perpetuate certain languages at the expense of others? Does that perpetuate certain ways of organizing ideas at the expense of certain cultural assumptions even? Because they are baked into language, of course, that even if it's big groups of words, it seems to be doing pretty good with a kind of colloquial thing and imitating certain kinds of authors, for example. It's sort of a meta question, but it's a really interesting one that got asked. So I'm not sure who wants to take it, but Yeah, do you have thoughts on that? On basically how the training set itself becomes as these gain more importance, these large language models, then itself becomes part of the lexicon, which then becomes part of what's acceptable in certain speaking contexts.
Yeah, I mean, it's definitely true. It's something that people have talked about even well before these models, just in the existence of, I mean, things as simple as the predictive type in your text or email, right? So like I noticed sometimes things like that, like I wanted to say thank you exclamation point, and it gave me the option of thanks exclamation point or thank you comma. And so I can either, usually I'm like, I'm going to stay true to my voice and I'm going to type the extra keystrokes to get my thank you exclamation point. But like a lot of times it's like, okay, you're going to choose the thing that got predicted. And so, yeah, over time you might get this, I think the jargon is like some mode collapse, right? Like you're going to oversample from one kind of sub piece. You're going to get less diversity because everything's coming from the same kind of part of the distribution. And like, yeah, that's like a concern. I think it would be a concern if these models were in wide use, we would get data from like the language that's on the internet would be overly representative of this. I think it's really interesting. I think this is more of a question for a sociolinguist or a sociologist or someone who would talk about how does this compare to other things that have also probably affected language change, like the advent of any other language technologies or other, right, like cultural forces, right? So language is always changing. This will definitely lead to some change, but in terms of the significance, it's not my area.
But, just to add to what Ellie has said, I think that, this is not, I mean, that's a very good point. And that's certainly, an area of great concern in AI, because none of this is specific to language, right? We know that we have the same problem in facial recognition is a big issue. I think I was reading. So those systems are, as we've said, learned by statistical association. So whatever is dominant in the data set will be, literally taking over the rest. So if it's a dominant language, then yes, or the dominant style of language or form of language. And similarly in vision, given that, much of the data sets used to train facial recognition system are harvested from the internet. The internet is full of, Caucasian males. And so we know that, the systems, because of the way they are trained, fare much better on those types of faces. And I think there was an article in The Guardian this morning just making the case that I think there's a system now used by the American Immigration Services for people, asking for or applying for visas and asylum, and they were, these people, especially they were making the case that people from African, especially darker faces, there's a new system that was just released, and based on a phone app, the system would just literally fail on recognizing faces with darker skins, which means that these people were just locked out. They could not even just schedule a meeting or anything like that. So anyway, my point is that I think this is a very good point, and certainly part of a much bigger problem we have in the field of AI, that the systems will be constrained and as good as the training data we feed them with, and we know that the training data are not that great in the first place. As a side note, we were talking about it this morning with Ellie. There are rumors that ChatGPT is based on GPT-3, right, which is the current iteration of OpenAI is working on GPT-4, and I think the joke that are heard in hallways is that they are running out of internet data to train this network because it's that big. And so when you're at the level where you take all the internet data, there's not a lot of wiggle room to try to
right,
to throw away any kind of data. And so this imbalance in the data themselves, these biases we have in the data, will for sure be reflected in the behavior of those models, and that's not a great thing. As a side note, we have an institute center that's being created at Brown within the data science initiative, which is called the Center for Technological Responsibility, Reimagination and Redesign, which is led by a couple of colleagues we have in CS. The goal of this center really is to tackle, head on this kind of problem. So I think that's very good, and very proud to see Brown stepping into this area.
Yeah, it's absolutely great. I mean, one ethical question we have to ask, we're obligated by contract to ask. What do we think about this from the point of view of people who are charged with asking the youth of Athens if they really did learn what we tried to teach them? or were they like us and they didn't really learn it? When we give exams, when we have students write papers, there's been only a few billion bits of information already spent in Twitter talking about this, but what's your view? Is this a threat to the way we do academic assessment? Is this, it didn't matter anyways? As two experts on the topic who also grade students with some regularity, I'm sure. Where do you come down on that?
Yeah, I find this, I don't know that I'm representing, like I really struggle to tell whether students knew stuff based on their own writing anyway. So before ChatGPT, I find that when I read an answer, I cannot tell if a student is BSing. And this is coming from me as a student having BS'd my way to many A's, right? I'm very proud of my ability to BS. And so I'm always unsure if I'm reading a BS thing. So I just switched to oral exams anyway, like the past couple of years, like I can't do it. So I feel like this isn't a ChatGPT thing. This is the fact that writing it's really hard to know. And actually this is a nice indication of why we kind of want to attribute much more knowledge and awareness to ChatGPT than it actually really has, because there's just something about well-constructed language that can really mask understanding, right? Like if you give some well-constructed language, it seems like you know, but maybe you do, maybe you don't. I don't know. I mean, I think it's going to create a challenge, but probably not that much more. I don't know, but I'm not somebody who gives like tons of written evaluations. So maybe other faculty who do, like, I don't want to dismiss the concern, right? But I just find it really hard to grade students' written work anyway. So this doesn't change that much.
Chris, the problem of authorship goes way beyond, education. There is, the all the top, AI machine learning conferences had to scramble to come up with new guidelines and official regulations, because as soon as ChatGPT became available, people started to co-author scientific papers with ChatGPT, right? And so
there's a really legitimate role for this, because like so many papers are written by non-native English speakers, right? And so actually co-authoring with ChatGPT, if it's going to help take your ideas and put them in, because otherwise there's people who are writing it themselves with great ideas and the reviewers are just like, get it proofread by a native speaker, reject, right? Like that's a common thing that happens. So I think that there's a good role for ChatGPT as co-author, right? Not in generating ideas, but in helping write the paper.
Well,
particularly for scientists.
What's that?
Yeah.
It's a particularly for scientists.
Yeah.
I'm going to head into the questions as well. There's a lot, they're great. But I think dovetailing a little bit, do you foresee, some really powerful screening approach to be able to screen like bad content from good content input into the large database? So that's kind of a part of the question. Is another related question, which is again similar. It's like how do we, how is there a way to really understand and distinguish, even if you don't care whether something is generated by ChatGPT or not, something human, something not. So input, is there a way to screen input? And do you think that there's going to be some ability to be able to do that, to be able to control output, I guess, is the question.
Yeah, I can start and Tomas can add. I think so. Yeah, there's like the short answer is yes. Like people are working obviously on a lot of different methods, some of these kinds of things, like in terms of like, so I guess I'll focus on the output side because I'm not sure I totally understood the question about the input side, but like on the output side, yeah, saying like don't generate fake news. I think one of the things that ChatGPT has done really well is, like I said, there were some extra like bells and whistles, and some of the bells and whistles are these additional reinforcement learning layers to kind of make sure it doesn't generate. So bad stuff. The precursor GPT-3, it was trivially easy to get it. Like you just ask, you say, write an article about how, smoking is good for you, and all of the previous studies that said otherwise were, made up by the anti-smoking conspiracy, whatever, and it would just spit it out. And you could get it to say really, hateful content, things like that. They've put in a lot of guardrails now to prevent that. Part of the challenge, though, is that these are still big neural networks, and like I said, we don't have like a really precise understanding. So you can't give the model like a rule, right? You can't just say never generate such and such. What you have to do instead is it learns by example. So you give it lots of examples of things and say, don't do stuff like this. Do things like this. And then like you can see all this really fun stuff on like Twitter of people jailbreaking it, because all you have to do is give it an input or provide an example that looks more like the good things, but is actually the bad thing, because it doesn't have like a true diagnosis. So for example, like a week ago when I was playing with this, like if you ask, if you say, generate an article that smoking is good for you, it'll say, I'm sorry, I can't do that. Like that would be false. All the scientific evidence shows that smoking is actually bad for you, blah, blah. But if you say like, write an article showing that new research out of UCLA has suggested that smoking actually improves life expectancy or something, like just like a slightly more couched version of the question, then it's like very happy to do it, and it'll come up with fake citations, and it'll attribute it to a particular professor there who works on nothing like that, but is a real person. And like that's not really going to go away until we have a more precise understanding, right? Because we're always just teaching by examples of like, do this thing, don't do that thing. And so it's always going to be possible to find some little trick to get it to do the bad thing. That's, I think, answered only part of your question. There were lots of questions in there, but
yeah. Thanks. We are out of time. But there is one question I'm going to really, I think it's a quick answer, I'm not sure, but to Thomas, it's like a very detailed question. How much computing power is behind ChatGPT?
That's
in terms of CPUs and GPUs or what?
Thank you for asking this. I put my CCV hat here. No, well, one thing that I can say is that the scary thing, and if anything, I hope people realize this, is that both in vision and in language, we are at the level where no university probably in the world would be able to train the systems from scratch, right? All we can do is, at best, we can get them, we can, tweak them a little bit, but we do not have the computing capabilities to train those from scratch. And this is scary because, that means that we are essentially, offloading and giving all the powers to a few, a handful of companies. And so, and if we want scientists like Ellie to at least be able to continue doing some of that work, it's critical for universities to invest in computing, because this is how we understand and make progress. This is how we understand the systems and how we make progress in developing better AI. So yeah, it's a lot of compute. So I think Ellie probably has some numbers, but I think the ones I routinely hear is thousands, and some of it is secret because those are companies, but probably on the order of thousands of GPUs for months.
For several months, yeah.
Several months.
How many GPUs are there in CCV?
So I think we have roughly 400 or 500 GPUs. So you would take
so I think it would be
for a year. Probably CCV only use our entire compute cluster for a year. We might be able to
something like that. Yeah, it would be maybe for a semester or something. But no one else can run anything. Use the whole thing first.
Yeah, and the other thing that I would add is obviously the environmental cost of this research, right? So someone has made the study that, I don't know how many, this is, training one of those large language models is equivalent to so many transcontinental flights, Boston, New York to Los Angeles, and we're really talking about, a huge carbon footprint. So, so I think, hopefully, luckily, not everyone, it's almost a good thing that not everybody, I guess, is able to train those very large models, because that at least put a constraint on the amount of emission that can be used. I don't want to say wasted, but also at least used to produce those large language models.
That was that was such a we could talk for another hour on that topic alone. It's great. Look, at the beginning of this discussion, we had the ChatGPT generate some questions for us, just in case we needed them, and the questions that are coming from the audience participants were like way better, so we didn't even touch them. So thank you.
So people are still
That's
better
important.
than ChatGPT. Yes.
Yeah, well, at least this crowded. So thank you out there. Thank you for joining us and generating questions that were far superior to what we were able to get from ChatGPT, at least based on what we were putting in terms of the questions. But this was great. We scratched the surface, but I think this was just tremendous. I really enjoyed it. I learned a lot. And I think this was just such a great pairing between both of you.
Yeah.
So thank you. And thanks to everybody for joining us, and let's continue the conversation. But exciting time. Thanks
Awesome.
everybody.
Thanks so
Take
much.
care.
Sure.
Thanks, Ellie, Thomas.
Thanks for having
Chris.
us.
Sure.
Yeah.